share his screen. Thank you.
Yeah.
Yeah.
Technical issues. Where was I? Oh, yeah, and Chris Pierce, who talked about, can't remember.
Sea cucumbers?
Yes.
Yes, sea cucumbers. Thank you.
Right.
Yes, yes. And today we have Tom Therriault, who's a research scientist with Fisheries and Oceans Canada, here at the biological station in Pacific Biological Station in Nanaimo. Tom is working on a number of aquatic invasive species and research questions on that. And he has authored or co-authored 160 publications, according to ResearchGate.
It's a lot.
And he's been part of studies on just a mind-boggling number of issues, and a broad, a wide range of approaches too. So things like risk assessment of zebra and quagga mussels, trapping methods of the European green crab, issues around implementing marine biosecurity systems in data-poor regions, managing and conserving marine habitats, and issues on climate change effects, and much, much more. So without further ado, Tom?
Am I on?
Yeah. So if
I
you
think it's
can,
on Zoom link.
Oh, is this part on?
Oh, there's a little.
button on top, yeah.
Okay. Is that there? Okay. Well, thank you for that introduction. Happy to be here. You're right. I work just down the road at the biological station on Hammond Bay there. And we do a lot of cool stuff that probably a lot of the public doesn't hear about on a routine basis. So I appreciate the opportunity to come and talk about my research program, which is on aquatic invasive species. And although federally we work mainly in the marine environment, we also do some work in freshwater. And you know, with that number of publications, I couldn't condense them all into a 1 hour talk. So I'm gonna pick some snippets that will sort of give you a flavor of the type of things that we do. I don't feel this is a really formal process, so I'm happy if you have questions as we go to raise your hand and we can stop and address them. So, you know, this work that I'm presenting is a reflection of a lot of collaborations over more than 2 decades. And so, you know, it's my name up there because I'm here talking, but there's a lot of people and a lot of funding sources behind the scenes. So just a little overview of what I'm going to spend the next little bit talking about. I'll give you a little bit about background on aquatic invasive species. A new component for me for this audience, I'm going to try it out, is a little bit of a game, native or not. We'll see how that goes. I'm going to talk about some of the priority setting work that my program has done to try to help the government of Canada be better prepared for a number of aquatic invasive species. Of course, on this coast, I hope most of you have heard about the notorious European green crab that's been invading our coast for over 2 decades now. It's certainly attracting a lot of attention federally and with coastal First Nations. So I'll talk a little bit more about that invader specifically. And then, of course, you know, it's not just the marine invaders. I'll talk a little bit about some of the freshwater invaders, some of the tools and techniques that we're developing to be better prepared on the detection front from a molecular perspective. And then a little bit like, well, what can you do as citizens out there? Obviously nature-based, thinking about, you know, preserving, conserving diversity. And as you'll see in a minute, you know, invaders are one of those key threats. And so understanding who they are and how to report them and what to do, I think will be helpful. And then, you know, some just general wrap-up conclusions and discussion. So just so that we're all on the same page, I went back to the Canadian Council report from 2004, where it articulates that an aquatic invasive species are those harmful alien species whose introduction and spread threatens the environment, the economy, or society, including human health. And in British Columbia, when we talk about aquatic systems, it really is a shared responsibility. DFO typically leads in the marine environment, also systems that have salmon, but the province is largely leading in fresh water. But I want to draw your attention to a couple of terms in this definition. So harmful alien species. So those are species that are not native to Canadian ecosystems, or they're from somewhere else. And then they have to be doing something, threatening the environment, the economy, human health. Like these are all, this isn't just the run-of-the-mill species. So we actually have a lot of non-Indigenous species, as you'll hear a little bit later in the talk, but not all of them classify as highly invasive. So we really want to target our limited resources on those species that are going to cause the most impact to those things that we have termed a value component. So as I said, the invasive species are not native to the ecosystem they're found. They can get here by a large number of means, both intentionally. There's a long history of stalking, both in marine and freshwater in this province, or unintentionally, hitching on commercial ships or recreational boats. These are all human-mediated activities that bring a species from its native range over some barrier to dispersal that prevented them from being here in the first place. And unfortunately, a lot of these vectors are not regulated. And so it really is a situation where we don't have enough powers necessarily to stop even some of the ones that we know are problematic. From a ecosystem perspective, invasive species are right up there with habitat destruction in terms of loss of biodiversity globally. Usually the culprit will be that crab that's competed with native species, or that species that's displaced a native species. And unfortunately, invasions, like other stressors in the system, are exacerbated by climate change. And we've seen here in the province over the last few years how climate change, extreme events are wreaking havoc on BC ecosystems. And the marine environment, although it's a little bit harder to see, it's not right in your face like the cyclone that we saw the other night, changes are happening under the water too, and we need to be more aware of those. Invasions, the rates are also changing. They're increasing. The more humans do, the more likely they are to take things with them. Often unintentionally, but that's just the reality. And we saw this during COVID, of what happens in a highly, highly connected society. And then again, the social and economic costs of these species. Here are some examples of tunicates fouling oyster cages. But there's consequences for a lot of industries that either have to mitigate or deal with the consequences of these invasive species. To the tune of about $423 billion US annually. And this came from a UN report that just came out. So this isn't, a little bit here or there. This is a big number. And if anything, it's probably an underestimate of the true damage. So what do we mean about invasions, right? It's not a start and end. It's actually a continuum. And so what I've shown here, and do we have a pointer? No, not.
Yeah, well,
Okay, I'll use my finger. What we have here is the area of occupation on the y-axis. So how widespread is the invader? How dense is the invader? And time on the x-axis. So if you think about it, in the very early stages, if you're entirely prevention oriented and successful, you don't actually have any invaders in the system. You've done a great job, you've kept them all out. We know that that's not true, and we know that at some point, whether you're trying or not, species get introduced. And over time, they start to spread and grow and occupy more space. And what that means is that the cost initially is relatively small. But when we get to the end, when you have a full-blown invasion, the costs can be substantial. And even though you think we don't want to spend money on prevention, nobody does. How bad could it possibly be? orders of magnitude cheaper to actually deal with these things in keeping them out versus long-term control. And just an example off the top of my head, the sea lamprey control program in the Great Lakes. So that, you've seen that thing invaded. That program on an annual basis amounts to something like $32 million between Canada and the US, just to keep them in check, not to reduce them, not to get rid of them, just to try to preserve fisheries in the Great Lakes. So as I said, I'm a research scientist. Our job in science is to inform management and policy decisions. And we're actually asked for advice through the entire process. So in the early stages, around prevention and early detection, we're identifying the risk of invaders. Where should we establish monitoring programs? Could we detect them if they showed up? And then more to the middle, when we're in sort of the control phases of eradicate or minimizing spread, it's, what are the tools we have? Can we reduce populations? Can we mitigate some of the impacts? And then unfortunately, we often end up way over here in the control phase, which is, how do we use limited resources to try to preserve as much structure and function in the ecosystem as possible? And unfortunately for aquatic systems, especially marine systems, that toolbox is very, very light on tools. It's sort of akin to a kid going to the basement and finding that dad's toolbox has one screwdriver and nothing else. So how are these species being moved around? Let's look quickly at some of the vectors and pathways. I'm not going to go through all of them. Some of them I hope you are familiar with or have heard. Shipping with ballast water and biofouling. That's how the notorious zebra mussel got into the Great Lakes, the goby as well. We know that recreational boats are moving species around. We know that people dump unwanted aquarium pets all the time, and I'll talk a little bit in more detail on that in a minute. Live food, people dump lobsters in Vancouver Harbor. We get a call usually about once every 2 years that sometimes the pins are still in the claws. They've just released it for freedom of the species or cultural release, what have you. The middle picture there, the large dock that washed up following the Japanese tsunami back in 2011. Almost 300 species associated with debris that arrived from Japan in that catastrophe. Clearly unintentional. We also have canals and diversions, which is not a big issue here in BC, but globally, places like the Suez Canal that's connecting two very distinct habitats. The Mediterranean has now got over 500 fish invaders that have come through from the Red Sea. It's also how the sea lamprey got from the lower Great Lakes to the upper Great Lakes once we put in the Welland Canal. So again, these are unintended consequences of some of our human activities. So just a little bit more on ballast water, because this is one of the ones that people are like, oh, what about ballast water? Well, so as you can see from the picture in the upper there, that's just a snapshot of global maritime traffic routes. We're clearly a very highly connected society. Ballast water itself is used for stability and trim of the vessel. So when the vessels are riding high, empty of cargo, they take on this water. It's unfiltered, it's untreated, it's got tons of organisms. The ship then goes to a new location to take on cargo, and it dumps out all of that water with all the associated organisms. And so it's responsible for a large number of marine invasions globally and a persistent problem. To the extent that there is now management under international convention and federal acts that align with that to try to treat and mitigate ballast water so that there's a treatment requirement before it's released. The effectiveness, we'll have to wait probably another 2 decades to understand how effective it's been, but at least we're making steps. And then biofouling, the stuff that's stuck to the hull of the ships, right now they're just at the development stage or drafting stage of guidelines that are completely voluntary, and as of last year, no countries were actually enforcing it because it was voluntary. And then down here, this is just a snapshot of movement patterns between different parts of the West Coast. And again, conveying that highly connected factor, but also just within British Columbia, there's no real regulation on treating ballast water or biofouling for vessels moving, say, from Vancouver to Haida Gwaii or Prince Rupert. So we have different flora and fauna between southern and northern BC, between Salish Sea and West Coast, and shipping is connecting those, whether we want to believe it or not. Another one that comes up is, we like to use marine resources or aquatic resources. And so often we will stock things for our pleasure or benefit. And this is where, stocking activities and angling, largely in fresh water, but also you can think of past aquaculture activities that have stocked Pacific oyster or manila clam, have also resulted in a number of accidental introductions. The issue here is that, it's not always an intentional release. Fishermen at the end of the day may lose bait off the end of the line. A lot of provinces, believe it or not, still allow live bait to be used. These things can carry pathogens, disease, etc. That's how whirling disease is being moved around the province. And because anglers like to create these opportunities for themselves, there's what we call the bucket brigade, where people just will take their favorite sport fish to their favorite fishing hole and put it in so that they're going to have a better opportunity down the road. And it's this, me first attitude that has unfortunately resulted in hundreds of lakes on Vancouver Island being invaded by smallmouth bass and largemouth bass. And as you can see there's a number of species on the freshwater side that we're actively thinking about and working on. The other vector and pathway I want to spend a minute talking about is organisms in trade. I don't know how many of you own an aquarium or water garden. One of the most common species that you'll find in the pet store, though, anybody?
Goldfish.
Yeah. You know what happens when people get tired of goldfish? They dump them in the lake. And so what we've seen in BC, especially several places in the BC interior, Dragon Lake, other places, you get these super high densities of goldfish because, hey, our climate's very favorable to these species. They don't have predators, there's no disease, there's lots of food, their populations just explode. And it's trying to target the responsible ownership of pets and not release them. That's one of the challenges. But given the high volume of trade in fish and invertebrates and plants, there's bound to be released to the environment. And so we have been looking closely at that. And then the other complicating factor in all of this trade is online sales. Now you can pretty much get whatever you want from wherever you want. And unfortunately, there's a large number of species, because BC's climate is so friendly, amenable for us, it's amenable for the species as well. So we had done some work where we had mapped this out. So just by our count, we identified over 1,600 species that are brought in on a routine basis into Canada. Almost none of these species are regulated. So you can't have an Asian carp. So those are the fish that jump out of the water and hit you. People have seen videos of. Yeah, so we banned those species, but pretty much everything else you can get unless it's a species at risk. And so what we had done here is we just mapped out, sort of all the challenges in the supply chain and how they can ultimately lead to introduction in Canadian ecosystems. And we did this in a geospatial way, which was super convenient when this showed up. Anybody know what this is? This is the mossball situation. So a couple of years ago, mossballs infested with zebra mussels because the mossballs were growing in a facility in Ukraine, where zebra and quagga mussels are native. And so The little babies were stowed away in these mossball products that were imported across North America. Almost every pet store in Canada and the US had some connection to this. But we were able to use our pathway analysis and some of the other work that we'd done specifically with zebra and quagga mussel before to help enforcement track down, decontaminate, and mitigate the problem. We're not aware of any invasion in BC because of this, but there has been at least 2 other events where contaminated product has hit store shelves. And unfortunately, it's not quite the same rigor as CFIA in terms of recall capacity. So if you have a recall on a bad head of lettuce or, oats or whatever, they can track that much faster than they can track, oh, who was the last 20 people that bought a moss ball? So this is the game part. So here's two oyster species. Anybody know which is native and which is not? Yep.
The top one's probably the Olympia one, the native one, and the bottom one is probably the Japanese one.
Yeah. All right. What about these clams? No. You think the native's on top? You think the native's on the bottom? Yeah. So the top is the manila clam, and very close sibling species here in BC is the Pacific littleneck clam. They come from the same family. Okay, freshwater. Come on, this is a little bit easier. That's correct. So those are native uniotid mussels. They don't produce the byssal threads. They don't clump like the zebra and quagga mussel that we're actively trying to keep out of the province. Crabs. A little trickier.
3 native.
Who said 3 native? You did? Do you know which they are?
At the bottom right.
Yeah, so this is the top one. There's the purple shore crab. Don't get fooled by the coloration. It's got more of a cube shell. Those are the ones that kids get flipping rocks on beaches up and down the coast. This little guy is a helmet crab. He tends to be quite hairy, sort of a pointy carapace. All the fishermen out there will recognize dungees. And then, yeah, the invader is the European green crab. And I'll talk a little bit more about that one in a minute. Last part of the game, freshwater fish. Any freshwater fish experts? They're all spiny rayed fish, and they're all not native. So these have all been introduced, and these are probably the 3, at least 3 of the top 4 or 5 species that you see in terms of widespread distribution. So if we think back now to just sort of the general context for where we are in BC, and I pulled this number from a count that we have from the Salish Sea, we've got over 160 non-native species out there, believe it or not. But as I said earlier in the talk, just because you're not native doesn't mean you're invasive. So a number of these species we're not overly concerned with right now, but that could change with climate change and other environmental change. And it's not just one group. So if we look at who the non-natives are, it's invertebrates, algae and plants, fish. There's harmful algae that we have introduced. Basically, almost every taxa is generally represented, except Chris Pierce's favorite, echinoderms. We tend not to see invaders in that group very often at all for some reason. And a lot of the associated hitchhikers are species that came with the traditional Pacific oyster industry 75 to 100 years ago, where the practice was just to go scoop up oysters and everything on it, bring it across the ocean and dump it out, and they're going to grow and you're going to harvest them. And that's a great idea until all the things that are on it start spreading away going, oh, I've got a new home. So BC, we have increasing threats on the freshwater side. Northern pike is continuing to spread in the interior. Parks Canada just shut down a bunch of lakes up north, adjacent to Jasper because of whirling disease getting into the province. Prussian carp is spreading across the prairies. And as I said earlier, BC's climate is really amenable to a number of these species, especially the coastal sections where we don't have, these really deep freeze winters. We have, fairly warm conditions, very temperate conditions, which represents a lot of our trading partners. And we have very limited resources. Again, the main control programs in Canada are centered in the Great Lakes, either around sea lamprey control or Asian carp. And then Washington State has actually spent a lot of money on the green crab issue, but Canada has not to this point. So given that we're inundated with all of these threats, one of the question is, which one should we be concerned about? And as I said in the invasion cycle, it's great if we could keep them all out, but we know that that's not always possible. So for aiding management and policy decisions, we really need to understand who the highest risk species are. And one way to do this is to create watch lists. And so when I was like, oh, this is a pretty easy task. We started this during COVID, right? It's a good desk-based exercise. It's like, okay, well, what's Canada's process? Well, actually, Canada didn't have a process. So we had to create a framework before we could start. And so that framework is designed around 5 elements: scoping, compiling a master list, conducting a primary assessment, often conducting a secondary assessment, and listing. And we identified some very clear conditions for each of these elements. And then depending on how this list, whether it's going to be used for regulation or policy or education, you can be specific. And then that provides the framework or the standardization that allows, different groups working on prioritization exercises to have some degree of comparability among lists. And so here's sort of the flow chart of it. And again, the process gets you to a list or usually for us, a series of lists of species that, you want in regulation, ones that you might think about monitoring, and species that you're just going to put aside for a little while because your other boxes are so full. But having the framework is only one approach, right? So then you need a tool. And we also didn't have a good screening tool. So we developed a modular tool that allowed flexibility around sort of the invasion consequence equation, where we know we have species that could enter the system, and then what would they do? And then, of course, the managers are always thinking about climate change these days. And we wanted a tool that wasn't just for fish or just for plants, so that we wanted a standard tool that everybody could use and put everything sort of on the same page. And so the background of this is risk is likelihood times consequence. And for invasions, it really means, can a species actually invade your area of interest? And if it does, will it have environmental or socioeconomic impacts? Again, going back to the definition that I mentioned earlier in the talk. And just to give you a snapshot of what I mean by invasion potential, it deals with, what is the likelihood that a species is going to show up? What's its dispersal potential? How many of them are going to come? How often? And these are all scored. And then it's combined with the impact modules where, we're looking across a wide range of endpoints, impacts on populations, community, ecosystem, conservation units. And then, are they going to affect the economy? Whether it's private citizens or government, human health implications, is it poisonous or venomous? Is it going to affect access to natural resources? And all of these get scored. And what we're able to do, and these are just a couple of snapshots from work we did for the BC interior, the Columbia Basin. We're able to look and see what the risk is in terms of both the impacts on the y-axis and the invasion potential on the x-axis, in these two panels. And then with the directional arrows, we can see, okay, well, what would this be like under a climate change scenario? So now versus 50 years from now, or now versus 75 years from now. So some of these species you might not be worried about too much right now, but some of these, the change in the not too distant future is pretty big. So you should be thinking about it as well. And just another way to convey this is just in terms of the overall ranking. And again, if your Latin is good, you'll recognize that quagga mussel is right there at the top of the list, Dreissena bugensis. But Asian clam, milfoil, Alodia. So again, a number of well-known invaders. And, not to get bogged down in the details in this presentation, but it generally worked well across a wide variety of taxa. We applied it to marine systems. It worked well there. So this is a tool that we're now using in our prioritization exercises within the department. And so the prioritized list can then be used by managers in terms of creating or adding to federal or provincial regulations. And I just want to take a moment to draw your attention to the fact that it's already legal for anybody to introduce a species to fish-bearing habitat under the Fisheries Act general regs. But the invasive species angle is meant to give additional weight to some of those regulations to try to get at the prevention part, which is we don't want to wait until you've already released it. We want to get it even before you've released it. And then it's a great source to take this list out to First Nations, industry, stakeholders, and the public, so that we get that common understanding of what are the species that, as a Canadian society, we're really most concerned about and want to direct some of our limited resources to. And again, feeding into awareness campaigns, establishing early detection or monitoring networks, and forming really the basis of a lot of new response and management plans, for which Canada largely was lacking, because only in 2017 did we actually federally within DFOs actually take on the management side to put together a plan outside of the sea lamprey Asian carp situation. So now I want to turn my attention to our favorite invader, or one of my favorite invaders, the green crab. So this is a shore crab native to Europe. The key distinguishing feature is these 5 spines on either side of the eye. In BC, the crabs seem to like it. We seem to have some of the largest green crab anywhere in the world. They get up to about 10 centimeters across, although most of them are sort of in the 6 to 8 centimeter range. This last leg here is flattened for swimming. It's a protunic species. And the key takeaway for everybody is they're not always green. And we actually have a lot of native species that are green. So color is not the best feature here. It's in the title, it's in the name, but over the last 20 years since we've been working on this species, inbox has been filled with green crabs that are not this, thankfully. But unfortunately, I've also seen people killing things that they think is this, and it's native crab. So that's why we're not advocating going and killing anything, but I'll get to what you can do later. So why are we concerned about this species in particular? I mean, this one has been on the global radar for quite a while. It's on the IUCN list of 100 worst invaders, one of the very few aquatic taxa that is. This species arrived in BC in the late 90s. It was first introduced to California via live seafood movement or bait worm movements in the late 80s, and then strong El Niños had it here by the late 90s. And then, 2018, San Juan Island, just out here on the US side, in the Salish Sea. 2020, the start of COVID and limited movements. We get a report from Haida Gwaii, and the island's locked down. We can't go there and actually do anything. And then Prince Rupert last summer, I found one 2023 for the first time near the mouth of the Skeena. So, you know, this species is on the worst invader list for a reason. It can outcompete our native crabs. It can decimate shellfish beds. It destroys critical eelgrass, and I'll show you some of those results in a minute. This species is a priority for DFO in Pacific region. The management side has control and response teams. And again, there's sort of a awareness campaign that goes to this species. But, you know, there's still a lot of things we actually don't know about this invader. And, you know, probably another career worth of activity just for somebody to get around some of those outstanding questions. But as you can see, you know, this species has been introduced around the world quite successfully. And the failed introductions don't mean that it won't succeed there in the future. So again, this is a species that we've been working on, or I've been working on specifically since the early 2000s. In the very early years, you know, we just had questions: where were they? What conditions do they like? Where could we expect to see populations? Where are they going to spread? We even had some questions about parts of the coast, like, are they going to stick around? Doesn't seem that great for them. You know, maybe they're going to disappear. So right here, the soup to the Central Coast plot, those are just pie charts showing the proportion of green crab catches. And as you can see, Souk and Barkley Sound and into Clayoquot, Nootka, you know, these were already, the catch of crabs was already dominated by green crab early in the invasion, which was an early warning that there was a problem. We also started to look at, you know, what habitats were they utilizing? Again, it's a shore crab. So not surprisingly, you know, sort of up to 4, 5, 6 meters is where most of the crabs were. And this is relative to the native gracilis crab, very similar to Dungeness. But as you can see, you know, it tends to occupy sort of the lower part of the beach into the subtidal. And that's reflected here as well in the relationship with salinity, where the gracilis needs that fully saline water that's deeper, whereas the green crab can occupy a whole range of salinities. And it's sort of this feature that really allowed them to get established in a lot of West Coast Vancouver Island estuaries, using it as sort of a beachhead to start their invasion into adjacent habitats. We actually don't have any native crab species that really likes those low salinity waters like this species. And then of course it's like, well, okay, so looks like they're going to be here for a while. Looks like their populations are growing. So what are they doing? And so what we did is a quick and dirty experiment looking at a couple of different size classes of a variety of shellfish. And as you'll note, some of these shellfish are actually invaders themselves. But European green crab were heavily predating on small species of all the clams and mussels. And so this was something that we're like, okay, this could be a problem. And then, you know, we get into the competition and damage caveats as well. So when we look at the global literature on what green crabs eat, don't worry too much about the colors. Just note that there's a lot of them. They actually don't care what they eat. They will eat almost anything. The purple there is just drawing your eye to in its native range in Europe, and then almost every invaded habitat globally. They're also huge predators on bivalves or clams. And the idea here was, yes, we understand that they eat lots of things, but is there something that they eat that we could track to really understand their impacts? And then ultimately, at the end of the day, when we think about like management and control, if we control the green crab, do those indicator species come back? So that's part of this story here. And we went at it through 2 ways. We did a whole bunch of lab trials, both at the wet lab facilities up at VIU, and then at our own facilities down at the biological station. And then, of course, anybody who's done lab trials know they don't always reflect nature. So then the next step is to go to mesocosms, and I'll give you an example of that. And so what we saw in the lab trials So this is varying densities of Japanese little neck or manila clam and varnish clam, and another high profile invader in BC. And the results, not surprising for a feeding study, are a little bit messy, but it really shows that there is preference for both of these species, and both could actually be used as indicator species. But Manila is a little bit more widespread. So that's the species we took out into the mesocosm work and did different density treatments. So, one crab per mesocosm, 3, 5, 7. And, not surprising, sort of by the time you get down to 5 or 7 crabs per enclosure, they were doing a pretty good amount of damage to the clams. And although it's variable, this starts to give us some information about a density that you want to avoid. So if you don't want to be above 5 crabs because they're going to destroy clam beds, we've got to get a way to get the numbers less than 5, right? So it actually becomes a management target. And then, we know that they're affecting crabs, all right? So we've got 2 native Hemigrapsis species that are widespread in BC, these cute little guys here. But work in California by Ted Groscholz's group almost 25 years ago showed that following the invasion in California, both this bivalve Nutricola and the Hemigrapsis, their populations were almost wiped out completely. And they haven't really recovered down there either. So we also were like, well, maybe we should be looking at the interactions with the with the crabs, with green crab. And so we designed this sort of cool feeding array here, where we're looking at habitat complexity ranging from bare sand to something that's fairly highly complex like nature. Different densities of prey, so different densities of Hemigrapsis species. We did it for both species, and we did it multiple times, and looked at feeding damage over about a 6-hour window that we could video. And these graphs show that both Hemigrapsis species were fairly heavily impacted, but especially Oregonensis, the hairy shore crab, across different density treatments and habitats. And so in terms of what we want to preserve these things. So this could be a good indicator for us. And just in terms of the relative mortality, it was averaging around 90% mortality for Oregonensis. And it's not that nudus, the purple short crab, wasn't affected. I mean, it still had close to 50% mortality, but both of these species were really hard hit by green crab. And I don't have the video here, but we have some pretty cool video of them just being shredded in seconds. The last impact that I want to talk about with green crab is eelgrass, because eelgrass is so critical. Supports our forage species, it supports our little salmon, it supports our little crabs, cycling of nutrients and decarbonation. And so we did again sort of the same thing that we had done with respect to the previous experiments, where we're looking at the density of green crabs in these enclosures, ranging from no enclosure or empty to a low density to a high density. And what you see here, not surprisingly, the high density treatment, the eelgrass was severely degraded and damaged. So again, in the lower density, I mean, there was some damage, but it was, in line with sort of natural eelgrass dynamics. The air bars overlap, but clearly different pattern once you get to 5. So again, it provides a basis that we could start thinking about it from a management perspective. Just quickly, in terms of where are they now? So west coast of Vancouver Island, they've been there since the late 90s, early 2000s, and have continued to spread. They were in the Central Coast about a decade later, and then, as I said, the Salish Sea, Haida Gwaii, Southeast Alaska, and Prince Rupert. Some of these locations, though, it's starting to change a little bit, but, as of a couple of years ago, we still have a lot of questions about how well established the species is in these areas. There was definitely a little bit of a boom, especially in US waters. But a lot of the sites that we continue to monitor, the crabs have gone down, and that may mean that they're not experiencing enough of the right conditions to stay there longer term. Compared to the west coast of Vancouver Island, where we found, literally hundreds of sites where we're doing very, very well. So our question is, will they persist in all of these locations? And the reality is, it's unlikely. We know that the green crab is at different invasion status, like up and down the coast, and that some of the locations, they're going to either meet unfavorable environmental conditions, or they're going to meet unfavorable biological conditions. And one of the ways that we try to convey this to managers is we try to, so this is a max and a habitat suitability approach, where we use environmental data to try to say, okay, well, we know where they are now. This is really good habitat. They're doing well on the West Coast. How much of BC is currently like the West Coast? And actually, not a whole lot, surprisingly. The caveat being, though, that as the invasion unfolds, so now that we've got, good records, so these were done before the invasion in Haida Gwaii and the Skeena, now that habitat is also known to be good. So these maps are going to change quite a bit. But one of the nice things that you can do with these types of models is look at climate projections and say, is the situation going to get better or worse? And generally, this is in agreement with what we saw. Actually, the red is worse, and so there's going to be more suitable habitat, especially as you move north. So, what does this tell us? Tells us that we have a potentially huge problem, given that we have thousands of kilometers of coastline that green crab could invade. And so one of the first questions for managers is, where do I even go look? I've got 2 people and 10 traps. Where do I put them, Tom? And I'm like, well, how badly do you want to catch a crab? So we went back, we used the MaxEd approach. We took 3 other modeling approaches, using a whole range of different input variables to try to inform like where managers should put their limited resources. And this little cartoon is sort of a reminder of our elementary school math, where when you have multiple models, there's different ways that you can extract information from those models. The mode is identifying the most frequent value at each site. The union is, well, if any model tells me it's good, it's good. And the intersect is, well, if the models have to be all in agreement before the site is good. And from implementation perspective, this means, because they want to know, well, which model is the best, which one, and it's like, well, it depends on the question, really. But the summary of what that previous graphic tells you is that the intersect models identified, very few sites and so this was probably a very too restrictive approach. They're going to miss sites that are going to have crabs. The union, though, identified almost, I forget what the percentage is. I think it's upwards of 80% of the sites as being suitable because one of the 4 models said it was good. And so this is probably not restrictive enough for early detection monitoring program. You're going to go and look everywhere, and you're going to have a lot of false positives or false negatives. And then the mode is where we thought we were sort of hitting the sweet spot, and it produced an intermediate number of sites, 50 to 90, depending on the combination. And so this is what we actually turned over to managers, and we said, okay, here's the mode of our various modeling approaches. Do you have groups in these little red blobs as the priority areas for early detection? And so they've actually been working with First Nations up and down the Salish Sea to implement monitoring programs at some of those sites. And then because we're always a little risk averse, we're like, yeah, and you should check some of the ones that are 1s and 2s as well, just just to make sure that we haven't miscalibrated our models. Just quickly in terms of what are we doing now? Well, we in science just continue to inform management decisions. So they come to us and they tell us generally what they want to do, and we try to tell them how to do it better. So the management team is divided into two targeted programs, one dealing entirely with early detection, working with community groups, First Nations, to trap areas that came out of the model and identified through other means. And then another team of a couple of people that are tasked with, now that we have a detection, now we got to go and respond. And so, there's two people that have been running up and down Vancouver Island all summer, working with First Nations to trap out sites where they were detected, and we feel that we have a chance of removal efforts being successful. And then for more information on the current status, there's information that's maintained by the Pacific Salmon Foundation, I guess as a proxy for DFO. This is from the management side, so it's not our data per se. It's sort of the collective data, and these are the sides that were provided directly for management. So those of you online or in the room, look at the QR code. It will take you to some of those managers' contact info. But as I said, you've got the 5 spines. That's what you're really looking for. But the key is take a photo, right? If they're going to respond, they want to know that it is a European green crab for sure, and convey information on where it was, what was the day, what was the site, lats longs if you have it, and then there's this 2 ways to report. Outside of the QR code, one is an email and one is a phone number, and I'll circle back to that, and you can look at it later offline as well. But the part of the management activity over the last couple of years is to actually engage other groups, right? Like you can imagine the situation that you have a species that could be at thousands of sites in BC, and you've got 4 people in your program. So they actually need trained volunteers, more or less. So there's actually some training available. It's actually a requirement if you want to apply for a license to remove green crab through their trapping program. But similar to the game that I played, it will tell you the differences between a lot of our native species and the invader. Really good background information. There's alert sheets and info sheets. And again, feel free to reach out to the AIS management team.
Is there any commercial value to these?
From a government of Canada perspective or my own?
Making money.
The reality is that there could be, but right now there is no commercial fishery. There's no market per se for this species. So you would have to develop the market. It is an edible seafood product. It would have, in my opinion, value as a food broth stock protein. I mean, it's just, they're so small relative to Dungeness, you're not going to get much meat. So you're not going to convince people buy and eat this versus Dungeness.
But down in Louisiana,
And the problem here is that we don't have enough information on the molt cycle to do like a blue crab soft shell fishery like they have on the Atlantic coast. So there are some challenges. I can tell you from a exploratory perspective, they're looking at it for biofuel, they're looking at it for battery, they're looking at it for fertilizer. So there's a whole bunch of people thinking about how to use this. One of the challenges that we have just with respect to the Fisheries Act is that any new fishery by definition needs to be sustainable. And obviously for an invader, you don't want it to be sustainable. Like you want to actually fish it down, which is, and the regulation is there because we've had such a mixed history with our commercial fish stocks that when we have over exploitation, we don't always respond quick enough. So we want to make sure that we identify when we're fishing down and we stop that. Here, we actually want to encourage it so that you actually fish them to extinction, but then your business model blows up because you're basically putting yourself out of business. So it is a very complex dynamic. The short answer is not at this point. But there are people thinking about it.
Do you have any ways discovered to counter this invasive species?
I mean, the only real way to deal with it is to trap it, is to remove it and kill it. You know, there's nothing that we can do right now with respect to chemical treatments. That would be illegal under dumping acts. There's no biocontrol agent right now that we have. That's becoming, it was taboo for a long time because of all the problems in Australia and New Zealand with biocontrol. Now, South Africa and a few places are having some success introducing weevils to control invasive plant species in freshwater systems. So I don't want to say that, you know, everything cycles, but we don't really have a lot of options right now, unfortunately. I know I have a few minutes left here. I just want to quickly touch on some of the freshwater issues. I've been talking about marine for a little bit here. You know, again, this is a shared priority with the province. Unfortunately, the governance structures to deal with invasives is not as clear as some of the other Fed-Prov relationships. And unfortunately, neither of us are, you know, sitting on a ton of money. So I think that complicates things. We have this historical priority dealing with those spiny rayed fish, the bass, the perch, the walleye, the pike, etc. Obviously, growing concern continues. We're getting increased calls about goldfish and other fish. I mean, almost every other year I get a call from somebody who's found a piranha or something up in Westwood Lake. I mean, it's just any unwanted pet. Instead of people killing it or taking it back to the pet store, which is what they would be advised to do, they feel it's better to keep it alive and they just want to release it to a stream or creek near them. But one of the growing concern is these crayfish species that we looked at, and there's a number that have really good habitat match with BC. They're in a number of vectors and pathways, and they have a large number of impacts. So red swamp and rusty crayfish, signal crayfish, they actually pose a problem. And again, there was historical use of crayfish as bait, which was, you know, then linked to the angling pathway. Whirling disease is probably one that I think is going to be hugely problematic going forward. It has really high mortality on juvenile salmon and other species. And then we've updated the National Zebra and Quagga Mussel risk assessment. I didn't talk about it here, but again, this was critical when we were dealing with the mossball situation. And again, it's what we're doing now is preventing or slowing the arrival and introduction of these mussels into the province. We know from studies that we've done of boats arriving both from the US. There's a number of hotspots in the Southwest that are invaded, and, you know, Winnipeg and Great Lakes boats that are coming with mussels. We've intercepted a lot and cleaned a lot, but again, it's like one of these things that if you keep rolling the die, eventually snake eyes comes up. And then just quickly, because I wasn't sure, we get asked about this all the time. eDNA is your friend, it's going to solve all your problems, right? And not quite that, but you know, it is a very useful tool, and that you can go from a water sample, do the back end, get the barcode, and match it up to a species as a non-invasive sampling method. That the cost has really come down. And so there's lots of challenges. I could have a whole hour conversation about the challenges of using eDNA in a regulatory context. But it does have a lot of strengths that I think in the future could be very useful.
So there's enough DNA, identifiable DNA, just in any drop of water that you can.
So that's one of the challenges. So there's collections that range from like a few mils to, you know, 1 or 2 liters. Generally in a well-mixed system, and it varies for taxa, right? Like fish that shed, you know, slime and scales and feces, you know, are really well represented. Species like crabs that have an exoskeleton, much less so. So understanding the limitations between species is critical. But for some of the species, yeah, a small amount of water, you will detect it. The question from a regulatory perspective is, how confident are you when you don't detect it? Proving the negative is almost always the biggest challenge, right? I also want to spend a minute just speaking, like, we're not alone in this fight. This is a global challenge. Invaders are being introduced to ecosystems around the world. It is a significant biosecurity threat. It threatens food safety, security, access. And unfortunately, as we've all witnessed over the last little bit, the changing geopolitical landscapes has complicated this. The lack of articulated priorities is a big problem. The European Union has generated a list of union concern. There's, I think, one aquatic species on the whole list. There's a whole bunch of terrestrial things that people probably that work in my realm anyways are like, how did they get there? Climate change, I probably don't need to say anything more about climate change. The challenge is that there's no real single entity that can deal with a problem of this magnitude. And so it really means to systematically forge collaborations, both, within the federal family, but, with stakeholders, with Indigenous groups, with community groups. And this unfortunately takes time. You can't just make people work together seamlessly. But unfortunately, the invaders are outpacing us. By the time we establish a collaboration, we've got 3 new invaders in the system. And so we have to become more efficient at working collaboratively on these large scale challenges. And then obviously changing human behavior is never simple. It's always a trade-off. It's always a balance. Yeah, sometimes you need the carrot, sometimes you need the stick. But the reality is, as people get set in their ways, but I always did this. I always dump my unwanted fish. I always angle this way. I always go to this area, right? It wasn't that long ago that we actually took the proactive step to ban felt waders to reduce the spread of invaders. So what can you do generally? Follow the regulations. They can be a pain, I'll admit that, but they are there in large part to protect Canadian ecosystems. There's also an ownership responsibility, right? So if you're a pet owner, don't let it loose. Do the responsible thing. Find a way to dispose of it that's not dumping your python in the Everglades. It's right. Like, we can think of examples. If you're a boat owner, clean, drain, dry. This is relatively quick, relatively painless for you, and highly effective for mitigating aquatic invasive species. It will get rid of the mussels, the milfoil, the diseases. Pull the plug, the same thing. There's various themes around this, but it really is, realizing that releasing species to the system, no matter how well intentioned you are, is never a good idea. And then specifically, I just blew this up. This is from the crab example, right? You think you've got something new, take a picture, right? Everybody's got one of these, right? It'll tell you where you are, when you were there. You don't have to think. When you report it, hey, I think I saw that green crab. I think I saw this fish. Oh, where were you? When were you there? And we have the ability now that we have databases that we're getting better at sharing, but we're like, oh yeah, that species has been reported there for a number of years. Yeah, just an additional confirmed sighting versus, oh geez, that's a brand new area. We actually need to send somebody out there to follow up or actually get a specimen. And again, these lines are monitored now. I'll put my age out there. I've been working for DFO for over 20 years. This actually just came to my email. That phone was my second phone line. At least now we've got somebody else involved, you know, in the infrastructure of an organization as big as DFO to say, oh, we can take those calls about those crabs, about those fish, about those suspects. And sometimes it's just a native species that people aren't familiar with. That's fine. It's better for us to know that people are out there looking and finding things and are concerned rather than, oh yeah, I saw that tunicate on that farm site 30 years ago. Oh, who'd you tell? Oh, nobody. I thought it was odd, but I didn't know who to talk to. So, you know, that's how some invaders persist in the system just because nobody knows they're there. So again, happy to take questions or discuss any of this. I think that's all I have. I don't think I have anything to add.
Hello?
I'm
Oh.
concerned about, like Diver Lake is purple loosestrife, that's nothing to do with their.
So purple loosestrife is technically an aquatic plant. We are concerned about it. I mean, we've seen what it, or I mean, I'm from Ontario originally. I've seen what it can do to wetlands in Ontario. It definitely has invasive behavior. It is a shared responsibility with the province, and unfortunately, those plants that are like a little bit in the water, but not necessarily always in the water, also then bridges the aquatic terrestrial divide in regulatory authorities.
I understood the whole bottom was whatever.
Well, some of the wetlands dry.
This mentioned.
So what we hope is that, oh, yeah, if it dries, oh yeah, now that's a BC problem. It's not our problem. Yeah.
Juvenile, does it differ from adult form?
So it has the exact same 5 spines, everything. It's just littler.
Okay.
So it just, yeah, each mold, it gets a bigger version of itself. Yep, and
I have just a simple question. So you said they can eat clams. How does this little crab eat a clam? Can he crack it?
yep. Yep, if you're on a beach, look, you'll often find the umbo, the end, and you'll see like crack marks around it. You'll also see like failed attempts like on the
Very strong.
yeah. Oh yeah, yeah. No, but they're both trying, they're just trying to get a little bit into it too, right? To snap the tendon. Yeah,
That's too many.
yeah, yep,
Got a couple questions on Zoom.
sure.
This was a while back that they have Asian carp in Lake Michigan.
No, the Asian carp are, so there's been detection of DNA in Lake Michigan. I don't think they have a body in Lake Michigan. There is grass carp in Lake Ontario. So, yeah.
I thought you were done.
Oh, no, I was just gonna say, there, the prevention strategy is, a bubble barrier, electric fence to, you know, keep the carp out. Again, any physical, barrier has the potential to fail. But the US, is spending a lot of money to try to keep the Asian carps out of the Great Lakes.
Second question was about, are there any native crayfish? You mentioned a bunch of.
Yeah, so we have one native crayfish in BC. Is it, the signal might be native to us and not everybody else. Something Pacificus. Somebody will have to Google that. But there is one native crayfish in BC. Some of the East Coast provinces have no native crayfish. Yeah. Oh, sorry, another Zoom one?
No, I think that's it.
Oh, okay.
Well, back on the west coast here,
Yeah.
saltwater. What about the Atlantic salmon?
What about that? I mean, they're not native. They're
Invasive species.
Huh.
That's
Why-
not in
why
by
are
the
they still
commercial route.
yeah, so this is why we're not recorded. The challenge is that the department has, so 20 years ago, I couldn't even talk about Atlantic salmon. because it was part of the culture program. The move is to get net pens out of the water. Whether that timeline is met or not, I will have to wait and see. What I can tell you is in terms of like release events, like accidental failures, those have actually gone down significantly over the last 20 years. It used to be, and the industry doesn't want to be losing product, but the systems that they had were just more prone to storm damage and tears and release events.
That do get out either way.
So we have not seen any evidence of spawning of Atlantic salmon in BC. So not to say that they're not doing things when they're out there, but they're not reproducing. So every Atlantic salmon you've seen is hatchery fish. So far. Yep.
Do you know why they can't reproduce? They don't need fresh water to reproduce, right?
They do go into fresh water to.
They're just fussy.
So, yeah, I mean, I don't know, right? So all salmon have some degree of homing. I don't know if they're just totally confused, like they don't recognize the cues coming out of, like the water conditions here are obviously very different from the East Coast or Europe, that they just don't recognize it, or they get in there and they're just out-competed. Like the systems that we have here are very different too, right? The coastal systems, they're flashy, they're not necessarily deep, right? I mean, outside of the Fraser or Skeena or Nass or something, but it's not like some of the East Coast rivers that, are deeper, slower, wider. But it's one of those things that, you release it enough times, you would expect if it was going to have taken, it would have by now, like because it's one of these things in invasion ecology. It's both the number of propagules that enter the system and the mix or the community properties. And so for a single species like Atlantic salmon, it really is numbers. Like we don't know whether it's 10 or 10,000 that you need to release, but the reality is compared to other species that we know have very infrequently arrived here, they've established from relatively low numbers. We know that, some of those release events were massive in their own right and could have led to an establishment, and they didn't. Yep.
Yeah, just curious, like, people often post on iNaturalist.
Yep.
And so they might, like, unknowingly, like, they'll post something and it ends up being an invasive species or whatever. Is that something that DFO monitors?
So we are, we have teams that are scraping those. The challenge is that, as you know, there are errors.
Yeah.
So some species we're better at, and the community is better at confirming. And like of the 160 species that are in the Salish Sea, I mean, there's probably 24 worms. Like nobody's posting those, right? It's the barnacles, it's the crabs, it's the mussels and clams, like and to be honest, from my perspective, that's actually good. Like we don't want, like, yeah, it would be great if we could know every single species confidently, but it's as problematic to get misidentifications and misconfirmations. And so if you can't be confident, right, I think we have to be clear on the species that we know and the species that we don't know.
So with the European green crab, so what do we know what limits their population in Europe? And
So
is there any sign that you mentioned that a few places populations are going down or stabilizing? Is there any evidence that predators or competition is sort of starting to?
yeah, that's a tough one. You hit a couple of them. So in the native range, the biggest issue is predators, competitors, and diseases. It's not a food thing, right? It's not a moth that needs a specific flower, right? They'll eat almost anything. So they're not limited that way. It does take time for our native species to recognize you know, green crab as a food source, even if they eat a lot of other crabs. Like there's an inherent risk if you're a predator to try something new. Because exactly, right? And then you don't make more of yourself. And so the challenge is, it takes time for predators to learn, and we've seen reports from the Central Coast where mergansers and other things have been, you know, eating green crab there. I've been up in Quatsino Sound, and I've seen otters going after green crab and got them on their bellies and digging them, you know, on the beach. So they do learn, but the question is, like, where are you in the cycle, right? And the problem is, like, if you take the native range, right, you're talking literally thousands and thousands of years that species have been co-occurring. Here, you're trying to say, well, if 6 otters eat the green crab, what will that do? Well, not much. You probably need 6,000 otters eating the green crab, right? So until those numbers become a little bit more realistic, the cycle is going to take time to balance, right? But a lot of classic ecology will show predator prey cycles, and they do align for most situations given enough time. And the reality is the sea otter situation specifically here in BC, I mean, we're still at the very early stages. In a lot of ways, it's got some properties of its reintroduction that are like an invasive species introduction event. It's, you know, so there are synergies out there. The big difference is that we made the otter disappear, right? So it has a right to come back to the system that it was once a part of. Where something like green crab was never here, it doesn't belong here, and shouldn't be here. And if it does stay here, we will see, you know, the damage, in my opinion, to eelgrass. There's lots of other things destroying eelgrass, but this is a big threat to eelgrass and all the species that rely on it.
This is the crayfish we have in Lock Lake. Examples how to do crayfish.
I would have to find out what species it is in Long Lake. Like I say, I know that there's one native crayfish in BC, and it should be easy enough to Google. That's what I would be doing if I was in my office. I wrote papers on it, but I can't remember which of the species I think it is the signal crayfish, but I don't want to quote me on that. If it was a green crab question, you could quote me, but crayfish, that's still new to me.
Okay, well, thank you very much,
Okay.
Tom. It's like a super thorough presentation about a super important topic too, and a tough one, right? Because it's very difficult to win. So ultimately, you're trying to do your best to
Yeah,
keep a handle on it.
there really is not a lot of wins in this world. You know, invasive species, it's just an ongoing threat. And, you know, the more, oh, sorry, I turned off my mic. The more that we can do to be aware, limit the spread, mitigate the impacts. You know, eradication is virtually impossible for a lot of these species. But the idea of targeted control and management, where you identify areas that you want to protect and preserve, and then just control the species in those areas is a good alternative. And it's the little wins, because if we don't eradicate it, we're doomed. I'm afraid I'm going to retire with no wins.
Thank you. Okay, I'll have just Chris come up to do the raffle.